All right, welcome back, class. Today we're doing all of your favorite word problems. I know they may not be your favorite, but one of my favorite, so you should like it too. Today we're building off of a relationship you might have learned more about in science, but you might also remember it from math. It's the relationship that rate times time equals distance. And when we solve almost any rate, time, distance problems, we're going to use a table, and we will oftentimes label them with rate, time, and distance. And generally, you'll need at least 2 additional columns. Sometimes you will need more, but 2 is a good starting point. And so let's get into this one. Let's see. SpaceX developed an autonomous hover car that can fly from Los Angeles to Toronto and back without having to refill for fuel. Ooh. It took 1 hour less to get there than it did to get back. The average speed on the trip there was 220 miles per hour. The average speed on the way back was slower at 200 miles per hour. How many hours did the trip there take? So, let's see. We have to go there. And we have to come back. So let's see. What do they give us? Rates. Let's see. The speed on the trip there was 220 miles per hour. So 220. The average speed on the way back was slower at 200 miles per hour. And what about time? They don't give us any explicit time. It says it took 1 hour less to get there than it did get back. So we don't know how long it took to get back. So that'll generally get a variable. In this case, I'm going to use the letter X. And it says to get there, it was 1 hour less. Right? It took 1 hour less to get there. So just a -1. So distance, they do not tell us any specific information about the distance. They don't tell us any numbers. They don't give us any relationships like how many more or anything. Because let's think. If I go somewhere and come back, in theory, the distance there and back should be the same, right? So really, these 2 distances should be equal to each other. However, we're going to need to use this information to help us solve for that. So if we do rate times time to give us an expression for our distance, and I'll need to distribute, I'll have 220x minus 220. Let's go ahead and extend out our table just a little bit. And down here, the slower rate times our time. That one's a little bit nicer. It's just 200x. Right? And we said these 2 distances, right, there and back, should be equal to each other. And that is how we are going to solve for our variable x. And then we'll see what did they want us to solve for specifically. So we want to combine like terms. So I'm going to want to move this 200x over here. And then this I'm going to want to move over here. Kind of like a little recycling thing going on here. So if I move this over here, I'm going to be subtracting 200x. And then here I'm going to be adding 220. So 220x minus 200 leaves me with 20x. And adding over this 220, there was nothing else over here, so I just have a positive 220. And now I can divide by 20 to get x equals, if my math is right, that will be 11. And so let's see, let's not just stop there at x is 11. Let's see. Question is, how many hours did the trip there take? Ooh, the trip there is x minus 1. And if x is 11, that means it took me 10 hours to get there. So this x actually represented the amount of time it takes me to get back from my trip. And you might be thinking, why does it take longer to get there? Or why is it faster there than back? Maybe there's some weather, something that is making it slower on my way back. Weather's probably the culprit. Wind, storm. So this is a common problem that you will see. This is a fairly realistic question to see how long was that trip. Now, books love to have these questions, and I am not 100% sure their total use, but you will see them frequently, so we need to know how to do it. So let's read this one. Your friend left school and traveled towards her friend's house at an average speed of 40 kilometers an hour. You left 1 hour later and traveled in the opposite direction with an average speed of 50 kilometers an hour, so you're a little bit faster. Find the number of hours your friend needs to travel before you are 400 kilometers apart. So let's do a little picture. Again, we'll make our table, but right, your friend heads off to her friend's house at 40 kilometers per hour. You just hang out for a little bit, and an hour later, you decide to also head off, but in the opposite direction. However, you're going a little bit faster. You're going 50 kilometers per hour, right? So at some point, as you guys get farther and farther and farther, you guys will be 400 kilometers apart. Why do we want to know this? When you get there, are you guys going to turn around and have a Wild West face-off? I don't know. But the question wants it, and textbooks love to ask these questions. So let's get back into our table of rate times time equals distance. And as I said, we generally need at least 2 additional rows. And let's see. So you have your friend. And then we have you. Right? It says your friend's rate was 40 kilometers an hour. Simple enough. And it says your speed is 50 kilometers an hour. Okay. Time. They don't give us a whole lot. It says your friend left school and traveled towards her friend's house at an average speed of 40 kilometers an hour. No time there. You left 1 hour later. If you leave 1 hour later, there's 2 ways to interpret this. Either you're driving for an hour less time, or your friend will be driving for 1 hour more. So you can see there's 2 ways you could write this, depending on what you want. So we're going to say that your friend was driving for 1 hour more. So we don't know how long you're going to drive. But your friend will be driving for an hour more since they left earlier. Distance. Okay, different from the other one, right? Distances may not be the same in this case. However, the relationship that rate times time equals distance is still true. So 40 times x plus 1 should give us the distance representation. 40x plus 40. And then here, 50 times time of x. Again, a little bit nicer in this case of just being 50x. And as opposed to last time where the distance is equal to each other, this time your friend's distance going this way plus your distance going that way, right? We want the distance between the two of you to equal 400, there's an x there, 400 kilometers. So let's look for like terms, x and x. So we have 90x plus 40 is 400. And then we want to move over this 40. So we're going to be subtracting 40. So I will have 90x equals 360. 90 times x equals 360. Divide by 90. And that will give you x equals 4. Do I stop there? No. Find the number of hours your friend needs to travel before you are 400 kilometers apart. Well, your friend has to travel for x plus 1 hours. So that means your friend must travel for 5 total hours while you are traveling for 4 hours. You could also think of it as your friend has to travel for 4 more hours after you leave. So if you call your friend saying, hey, I'm leaving, let's see when we're 400 kilometers apart, and then turn around and face off, right? From that point, it'll be 4 hours. However, it'll be a total of 5 hours that your friend will have to drive until you guys are 400 kilometers apart. I hope this made sense. Rate times time is distance. Moral of the story, use a table, be neat, show your work, and I will catch you in the next one. Pew!